Hi, welcome to join. Cool, so I'm going to talk about Programmatic LookML for flexible schemas. But first, who am I? I'm a consultant with Looker Professional Services. If you're not too sure who professional services are, we're a group within Looker that focuses on basically reducing your time to value, literally getting you up and running quicker. So focus on initial implementations, teaching how to use LookML, how to use Looker, all of that kind of stuff. Maybe mature deployments on focused projects like driving user adoption, maybe some kind of a health check. And I wanted to share with you today this technique I've been using regarding programmatic generation of LookML. So this is what we're going to go through today. 3 things. First, why? Why are we even bothering doing this? Now, if you create a project, you click scan tables and schemas, Looker will generate your LookML for you. So why are we doing this? When we talk about that, I want to think about why we're doing this in terms of a live example. So we're going to generate some LookML on the fly. We're going to stick it into Looker. We're going to run some queries, and we're going to see what our results are. And then finally, I want to leave you with the libraries that I've been getting started with. There was a great talk over on the blue stage just now that was introducing a couple of these libraries. And they're all written in Python for me. The code that I'm writing is written in Python. So I just want to introduce you to those and show you how you can get started. OK, so why are we doing this? Now, I know there are a few different reasons why we might want to do this, why we might want to programmatically generate LookML. But I think the main reason probably is to do with flexible schemas. Now, flexible schemas are a way of storing data where your dimensions, where you're storing that data, can be changed, updated, created, or deleted just on a random time frame. And because your data model is changing really rapidly, your LookML model has to update constantly. Your LookML model is describing your data model. So when your data model changes, your LookML model has to update. Why would we create these flexible schemas? Well, it's all about customization. It's all about creating user-defined fields. So imagine you have like CRM software, some customer relationship management software. Now, business A might use that software to categorize their customers in one way. Business B might use it to categorize it in a different way. So you have a series of dimensions that are being captured by user business A, series of separate dimensions being captured by user B. And then there's user C, D, E, F. Suddenly, there's a huge, huge data model, and there's a huge amount of customization. So the only way to store that is in an EAV, an entity attribute value data model, or a flexible schema. And naturally, when that data model gets updated, like I said, we've got to update our LookML model. Think about research data. If you're a research company, you're constantly generating hypotheses. Those hypotheses have to be tested with a series of questions. And when you create those questions, those have to get stored in your data model. So you're constantly creating dimensions, constantly kind of shoehorning things into your data model. On those changes, you have to update your LookML model. So the second reason I was thinking was, let's think about creation or maybe updating a LookML model based on some kind of stimulus. Imagine a process where you will scan your LookML model and identify unused fields, maybe, and then regenerate your LookML, hiding those unused fields. So you're cleaning your LookML model. You're cleaning your explore as it goes. One of the really frustrating things that I see in PS is people with verbose explores. People just like to, stitch joins together. Oh, there's another view, I'm going to put it in. Here's another view, I'm going to put it in. And then you get an explore with just, a ton of fields. The next person that comes along, they don't know which field to select. And everyone, it's very, very difficult to start using Looker, to explore Looker, if you don't know which fields to select. So this is a way of kind of cleaning that up. And then the third reason is arguably one of the most powerful. If you're a developer manager and you are in charge of trying to orchestrate 5 different developers, the easiest way to do that is to come up with your own custom-defined rule set. Maybe you use comments in an interesting way. Maybe you always have your measures at the bottom and your dimensions at the top. Maybe you always have view labels that are kind of aggregating some fields together. rather than taking that kind of vanilla generator and then stitching those rules in, this way you can just create your standard rule set straight off the bat, put it into Looker, and off you go. OK, now I spoke about a live example, and it's kind of live. But I want you all to imagine that you are professional services consultants with me, and we're going to work on our first business together. And that business is called Acme Corps. Now, Acme Corps is a multi-tenant business. It's a business that hosts data from other businesses. And those businesses are service companies. Think of electricians, plumbers, contractors, et cetera. Have you ever taken delivery of an oven or something and had to sign a form? Have you ever called out a plumber? If you, that phone call, the logistics behind sending someone out, the stock where the plumbing part needs to come from, all of that is being stored by Acme Corps. But of course, each plumber isn't the same as an electrician, isn't the same as a contractor, so they need to define their own rules. And Acme Corps allows you to create your custom fields. So Acme Corps will allow you to capture all the data that you're interested in. Now, naturally, Acme Corps want to level up their BI game. They want to allow self-service analytics. And so they've chosen Looker as their BI solution. But the challenge is, a service company can change or delete or update those custom fields that they capture whenever they want, at any time. And so we need to write a model. We need to help them write a model about how to do that. Now, naturally, as a good professional services consultant, we sit down, we engage with the customer, and we may hear phrases that we don't know, and when we do, we go back home and we Google the hell out of it. So what is an EAV? Now, an EAV is a way of capturing data when there is a huge amount of variability in the amount of and the attributes that you're capturing. So think about on the left, your standard kind of data table. You have, think of it like an orders table from an e-commerce company. Your entity might be the who's ordering. So Hugo's ordering something. Your attribute might be the order ID, the order date. Maybe there's a promotion running, and each row is an order. Now, if there isn't a promotion running, that promotion field just gets stored as a null, which is fine. But now let's apply Acme Corps to this. Now we have a tenant ID, an EID, an entity ID, and that first entity is only capturing data from attribute 1, 2, 3, and then entity 2 is only capturing data from attribute 4, 5, 6. And so you end up with this huge, wide table, which is just filled with null values. And those null values mean that you're storing data that you don't really care about, and you're having to access data you don't really care about. So the solution is this EAV, this entity attribute value data model. So within this, we just have our tenant ID, our attribute ID, and this time we have a series of key value pairs, an attribute name and a value, attribute name, value. And that way we can eliminate those nulls. And so we have this very kind of clean storage mechanism. We're taking that wide table and making it really tall and thin. Now, this is an example of what EAV might look like. So we have, for Acme Corps, this might be our entity, the attribute for the column name, and then the value. And then what I want you to pay attention to here is the metadata. So the metadata, the data type with decimal, string, what type of thing is it, with the value format, we can use that metadata to inform our generation of LookML. But there's a problem with EAV. It's kind of cool to store it, but it's not very easy to do any analytics on it. So if you write SQL against EAV, you've got to do some kind of a transformation first. And this is how we're storing it, and then you transform it, and it comes back to this with our null values, which is fine. Now we can write, select attribute 1 where elec1 is true, or something like that. But remember, we're not storing it like this. We're storing it like this, so we always have to do that transformation. And that's frustrating, because when we're generating LookML, now we have to write this transformation. We can't just write a standard view. So now we're going into derived table territory. But I'm getting a bit ahead of myself. Let's first generate a view just to prove that we can. OK, so this is our first introduction to the libraries that we might be using. So this one's called LookML. It was authored by Garner, who is in the back right there. And what we're going to do is we're going to run this code just to generate a view. And so off we go. And what we've done is we've generated this syntactically correct view called order items. Now we're going to add some dimensions. And now I've added an ID, a value dimension, and a dimension group. Again, syntactically correct, pretty easy. And so we've got this view. And then the final thing we're going to do is we're going to set the SQL table name. Off we go. So now we have our dimensions in a view with a SQL table name, public to order items. I can take this, it's pretty straightforward, I can copy it into my LookML model. I've now first programmatically generated LookML. But there's more. Now when we're thinking about this, we have to do that transformation. And that transformation has to be based off of our data model. And that data model is going to be our source of truth. So we need to figure out a way first to scan that data model that will then inform our LookML generation. And we can do that via API calls. So we can literally just run a SQL statement via SQL runner, run that via API, which will return the results of our EAV data in an API response, and then use that to inform our LookML generation. So that looks a little something like this. And I'm just going to take a step here to say, don't worry so much about the line-by-line code here. All of this is going to be available to you in a Git repo after the talk. So don't worry so much about the individual lines of code. Just kind of concentrate on what's happening. So in this case, what we're doing is we're going to take our LookML gen and an API call, and we're going to generate a select star from the EAV data, which is going to give us our response. So first of all, we now know how we're going to scan that data model. Now we need to figure out how are we going to flatten that data. So we need to do some kind of a SQL transformation, and that will look something like this. I'm not going to go really too far into this because there's various discourse articles about this. Essentially what we're doing is we're grouping by schema ID and entity ID, and then taking a series of aggregates to transform our column value, our one column, into a series of other columns. We're taking that tall, thin table and expanding it out. OK, so we know we can generate LookML. We know how to scan the table. And we know we can now get that SQL statement at the base. The other thing I just wanted to mention is that there's a series of entities in here. There's a series of different customer data. So we also need to add some security to our model. We need to make sure that each entity, when they're looking at this view, can't see anybody else's data. So we need to add some kind of column level security. And in Looker, that's quite easy. That's called an access grant. And that's based off a user attribute. So that user attribute will mean that each person accessing their view can only see the data fields that are appropriate to them. So we're building quite a challenge for ourselves, and Acme Corps are keen to see if we can raise that challenge. But the final step of this is, how are we going to deploy this? Now, deploying LookML programmatically can be done via Git. And that's because we're storing all of our files in a Git repo. So we can clone that Git repo, and then scan our source of truth, our data model, programmatically generate our LookML, write it, delete it, do whatever. And then we have to write that LookML, that updated LookML, back to our cloned repo. Then deploy it via webhook, and then our code's back. It's back on this master branch, updated, and we can use the Looker API to do whatever we want with it. OK, so I've stalled long enough. Let's actually see it working. So imagine this output directory. This is where the cloned repo would be. And what we want to do is we're going to, first of all, scan that data model. So we're just going to do a really simple select statement that's coming from the EAV data. Now we have our API response. And we can use that data model to then build that SQL statement that we had at the base of our derived table. And then using that great library we were just looking at, creating a view, we're going to call it a volatile view, because this view is going to get regenerated. We shouldn't be writing in this view. We're going to stick the SQL statement we just built in the SQL of a derived table and set the folder where we want it written to that output directory. Then as we go through, we can see from that metadata, is it numerical? Is it decimal? Therefore, we can then set the type as a number or a string or a dimension group or whatever you want. And then we can set the field level permission for your entity ID. Then we will just add it to that view, and then write it. So now we're writing. The second step is we're going to take those access grants, which are now in each one of these dimensions, and then write a model filled with access grants. So first of all, the volatile view will look something like this. So I've added in just a string that says, this is an auto-generated view created by Python, whatever. This is the derived table. Because it's a volatile view and it's going to be regenerated, I never want anyone to develop in this view. So it always has to be extension required. Okay? And then we can see there's a required access grant. Everything's syntactically correct. I don't need to worry about messing it up. And this is a type string. We can see, if it was a scale of 1 to 10, it's figured that out, and now there's a type number. So we're looking pretty good here. The second stage is that model. Now, this is just a really simple model that I use to include into my other models, and that means that I'm not messing anything up. And what it looks like in terms of looker is this. So here's my auto-generated view. You can see all of my required access grants, and then this is my access grant model, which I then included here. So this purely is a model, for access grants. And it looks something like this. So now I have my entity ID, my schema ID, a series of dimensions that are applicable only to me, defined by my user attribute. And then I just threw in some measures too. This is just like a sum, and I've given it a name of total, just to prove that we could. But what I want you to see is, if I go and sudo as somebody else with a different user attribute, the fields update. And so you can see there's no more location name, for example. There's no purchase date. So all of my fields are being sliced off based on my user attribute, which enables me to maintain that security. So cool. Acme Corps, they're really excited. They know now how to programmatically generate LookML. They know how to scan that source of truth. They know how to deploy it. They're pretty stoked. But they come back to me and they say, Hugo, you've done really well. You've done exactly everything that I asked you to, but we contracted with you to talk for 30 minutes, and you've still got 10 minutes left. Can we have a refund? And I say no. Let's talk about bonus rounds. I've got some other stuff for you. So I was kind of alluding to this auto-tuner. And the auto-tuner is a really, really great thing. One of the main problems we see in PS is messy models. So messy models meaning just because I can, I should join. Just because I can, I'll stick this extra field in. We as analysts build things for other analysts. We don't build it for the regular people. And I would argue that the definition of success within Looker is when your whole organization is making data-driven discoveries, not just you as analysts. This isn't an exclusive club. So using these existing packages, such as Henry, such as LKML. So Henry, if any of you don't know, is a command line tool written in Python. It will scan your history table of your model, and then identify which of your fields aren't being used, which of your joins aren't being used. And then LKML was just kind of mentioned on that blue stage, authored by this man, Josh Temple. I'm not sure if he's here or not. But basically, that takes your LookML and it serializes it into a series of nested dictionaries. And once we've got that, we can then match up the two. So let's take a quick look at that working. So here's our pruner. And first of all, let's look at Henry. So this is an example of a Henry output. So yeah, we've got our unused joins, we've got our unused fields. And I just want to kind of call out that users.age. Okay? And luckily, I've got some LookML here from a users table with a dimension in it for age. So this is my pruner. Now I'm using pandas just to kind of put that CSV into Python. And then I'm using LKML to serialize my LookML right here, LKML load. And then literally looping the two and saying, if there's a field in one and there's a field in the other, then hide it. And so we can run that code. And if you're curious what serialized LookML looks like, this is what it looks like. And right at the top, we can see users.age is unused, so we're hiding it. And then we can verify that with our dimensions. Here is the dimension for age with a hidden yes. And there we go. So now we can programmatically call call Henry, figure out what is not being used, and then update our model. So we can transform, we can update, and Acme Corps, they're really stoked. They're like, I didn't even think that we could do that. Like that's a pretty cool use of that tool. We can regenerate that LookML, like pruning the model. But they come back to you and they're like, Hugo, we contracted you to talk for 30 minutes, and you've still got like 8 minutes left. Are you going to give me a refund? I'm like, no. Let's go more bonus rounds. Let's talk about custom view templating. So I had spoken about this a little bit earlier on, and if you're a manager of a series of developers, your best bet on maintaining a clean instance is defined hard and fast rules. Linters are your friend. Clean explores are your friend. What you want to do is make sure there's a series of code rules that you adhere to. And the easiest way to do that is to make sure that you define a template that you want to stick to, okay? And the best way to define a template is to not use a standard LookML generator, but instead to have your template just generated off the fly. We'll still need to scan that source of truth. We'll still need to scan the data model. And we can do that doing that API call. We can now scan the information schema rather than a specific table. But once we do that, we can start to put in interesting comments. We can aggregate all our date fields using the view label. We can add custom design patterns. So LookML is an abstraction of SQL. But what if we were to abstract it one step further? What if we were to say, let me just write in a method in Python, and then I'm going to generate some really complicated liquid. So let's take a look at that running. Where is it? Here we go. So here we've got our API call where we're cloning that repo to. And here we go. Here's our SQL statement. We're scanning that information schema. And then we can use that API response to build our programmatic LookML. And then once we've done that, we write it and then deploy it via webhook. If there's an integer or a double precision, then we're giving it a type number. If a column name's ID, we can set the primary key. But in this case, I want to add a comparison period. And what that comparison period is going to do is this. So in this case, we're going to write a filter. And it's going to type date. And we've got some liquid in here. There's date start and date end, which is pretty cool. And then we've got a reporting period filter. And then we have two measures, which are only going to be true when that comparison period is true or when the reporting period is true. Normally when you think about how to generate this type of liquid, you first think, right, I need to do some kind of period-over-period analysis. OK, let's go on a help desk, and I'll find the code sample. And then I'll stick that code sample into Looker. And then it doesn't work. And so then you futz with it a little bit, and then it still doesn't work. So you go on to chat, and then chat will solve your problem because they're awesome, but it'll take you like 2 hours to do it. This way, we're doing it just straight away, instant auto-generation. And then we get a look that will look like this. So now we have our comparison period filter, our reporting period filter, and we can look at, I want to say compare last year for 1 week compared to last week. And maybe this will work, and maybe it won't. We'll see. There we go. Cool. So now we have our reporting period, our comparison period. I just put in a really easy period-over-period change. But we can generate this, stick it onto a dashboard, and very easily now we have a series of analytics. So remember I was talking about generating a model based on some kind of stimulus. Imagine somebody creates a survey or something, and then you want to build that model straight off. So you can build that model. You can start to, you know what the types of fields that might be going in. You can create these abstracted analytics, stick them onto a dashboard. Instantly, these people have custom analytics based on something they created 2 minutes ago. Thanks very much.